right, we're going to start in 1 minute. Looks like my mouse batteries are running low. I'm going to start in 1 minute, guys. So please make sure that you grab your book. If you don't have it near you, go grab it. We're still in book 1, so we're still in volume 1, but we're in module 2 now. So you have to go to page M2 121. So we're not in module 1 anymore. All right, and it is 9:48. So I'm giving you guys a minute to get your book and turn to page M2 121 as people come in. So I'll probably give you guys the first couple minutes class to grab that. Make sure you have a pencil. If you have a highlighter, get a highlighter. If you have different colored pencils, you could do that too if you want. I don't have different colors on this app for some reason. I have it on my iPad, but not on my desktop. So we'll start in just a few minutes and give everybody a chance to get their book. We've got 17 people out of 25, so we're still missing quite a few people. So again, you're grabbing your book right now, turning to page M2 121 for some notes today. I got it.
Hopefully those are charged.
Okay, thanks. I'm gonna go grab the batteries for my mouse. Okay, so again, you're getting out your book, turning to page M2 121. We're gonna start in like 1 minute. Again, make sure you have a pencil or a pen, and then you need to have a highlighter if you have one, would be helpful. And if you want to use different colors, you can, so you can maybe have a few colored pens or a few colored pencils if you want. All right, so today we are going to still talk about like the opposite, adjacent, and hypotenuse stuff. However, in the context of your book, they have us proving triangles are similar using these ratios. So normally we would do like small divided by small, medium divided by medium, and large divided by large. However, because now that we're in trig, we need to start using opposite, adjacent, and hypotenuse. So we're going to be proving triangles are similar using those ratios just to kind of be really familiar with those ratios, okay? So that's all we're doing today is proving that we're gonna have two different triangles, two different sets of triangles, and we're gonna prove that they are similar using the ratios that we've learned yesterday. All right, so again, if you just came in, you need to take out your book and turn to page M2 121. I'm gonna go ahead and get started, okay? So M2 121 in volume 1 of your book. And in fact, when I scroll down, the page number is still up there if you need the page still. All right, here we go. Okay, so the first thing that we're gonna do is we're gonna create two triangles from these lines. So we have lines M and N, and they're parallel. So we're gonna draw in two triangles. Okay, so the first thing you want to do is on line N, pick any point, kind of up towards the top a little bit. And then you're going to draw a line from that point all the way down to point J. And we go to point at point L. So then we're going to create the bottom line of our triangle from J to L. And then we're going to create this side as well. And I've been having issues with this all day. There you go. All right, so there's one triangle. Now we're going to create a second triangle inside of this triangle. So I'm going to put a point on line M here, and then I'll just kind of highlight point K, and I'm going to draw a line down here. So there's my other triangle. So now I have that big triangle on the outside. Oh, Nick, that sucks. We're on our book, page M2, 122. And so if you see here, I have this little triangle on the inside. And then, of course, I have the bigger triangle that I started out with on the outside. So we have two triangles now. And again, we want to prove that they're similar, but we're going to be using ratios for that. All right, so, oh, and we need to label our new points. So this point is going to be point Q, and this point is going to be point P. Okay, and also let's mark this as well. These are both 90-degree angles because we're supposed to create perpendicular lines there. Okay, so we did number one. Number one was creating these triangles. Number two is asking you to prove or verify that these two triangles are similar to each other. Now we're going to be doing that in a minute with actual numbers, but if I didn't have any numbers on this triangle, you still could prove that they're similar. So in the chat, I've given you a list of possible theorems that would prove that these two triangles are similar, and you're going to just kind of take a guess on which theorem you think it is, okay? And you need to answer, because this is how I'm going to grade your participation for today in the chat. So I have four options there: angle, side angle, side angle, side, angle, angle, and side, side, side. So you're going to take your best guess on which one of those four in the chat do you think would prove these two triangles are similar without having any numbers written down yet. Okay, so I'm going to give you a minute to take your guess. And if you're not sure, like, just take a guess. Okay, this is your participation for today, is the chat. Lots of angle, side angle today. Every period is different. It's really funny. Give everybody a chance to answer. Again, please do take a guess. I'm recording the chat so that I can give people points for participating today. Oops, I didn't mean to scroll down. Okay, everybody have a chance. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 20, 21 people. We got 25 people in this class. So, all right. Here we go. All right, so the answer is actually angle, angle. So you guys were close. You said angle, side angle. But the answer is angle, angle. Okay, so I just want to write that down. So over off to the left here, you guys can write it in under number 2, but I don't have any room under there. So for number 2, the answer is angle, angle. The reason is they both share angle J. So take a look. Angle J is right here. They both share that angle, right? Like the little triangle has it and the bigger triangle has it. So that's one angle that they have in common. And then, who was it? Was it Jonathan that was pointing out they both have a 90-degree angle? Yeah, Jonathan was pointing out they also both have a 90-degree angle. So that means that these two angles are the same. So angle K and angle L are both 90-degree angles. So we'll say, and they have 90-degree angles. So that's two angles they have in common, which means angle, angle, right? Because then the third one has to be the same. So angle, angle, if I didn't have any numbers, which I'm going to give you numbers in a minute, but if I didn't have any numbers, I could say, well, angle, because they have two angles in common, angle J and then angle K and L, both are 90 degrees. Okay, so make sure you have that written down in number 2. And let me erase this. Just for, so you know, angle J is going to end up being our reference angle here. All right, so let me scroll down a little bit. All right, so we're going to be taking these ratios. I want you to write this down under number 3. These are the ratios we'll be doing. And then I'm going to give you the side lengths that we're going to write on our triangles so that we can actually do the division. So let me go ahead and start giving you the side lengths. So please write this down and also write down, like I said, this underneath number 3. So the hypotenuse of the large triangle, triangle JP, that one is 6.5. Okay, and I know this because I've already measured them. So if we were in class, I would give you a ruler and I would say, hey, measure these in centimeters, and you would measure them and write them down yourself. But we're not in class, so I can't give you rulers. So I'm just giving you the measurements. Plus, we only have 30 minutes, so I'm not going to waste time measuring. You guys know how to use a ruler. All right, side LP, that side is going to be 3.8. And then side JL is a little bit too big. Make it a little smaller. Side JL on the bottom there, that one's going to be 5.3. So that's for the bigger triangle. Now for the smaller triangle, the hypotenuse is 3.7. The right side is 2.2. Let me fix that. 2.2. And then the bottom is 3. Bottom is 3. So make sure you have all these measurements written down. And now we're going to start our ratios. Okay, so we're going to be using, like I said, the opposite over adjacent, opposite over hypotenuse, and adjacent over hypotenuse to prove that these two triangles are similar. So let's take a look. And remember, angle J is going to be our reference angle here. So if you want to bold it, I guess maybe you should, right? That's our reference angle there. I wish I had different colors, but I don't. It's annoying. Okay, so here we go. So I'm going to start with KQ divided by JK. So side KQ is this side right here. So that's 2.2. So I'm going to write 2.2 divided by side JK. So JK is the bottom here. JK, which is 3. So I'm going to do 2.2 divided by 3. That's 0.7. And if you look, that was the opposite, right? The 2.2 is opposite angle J. And then the 3 is the adjacent. So we did opposite divided by adjacent. So now I'm going to do the same thing for the bigger triangle. I'm going to divide the opposite by the adjacent and see if I get the same number. So let me erase these ones. So this one is, like I was saying, if you want to use different colors for these, you totally can. Not required though. All right, the next one, LP. So LP is the opposite side on the big triangle, so that's 3.8. Divided by my adjacent side on the bottom, which is this side down here, that's 5.3. And I should get the same number once I round it. So 3.8 divided by 5.3, that's also 0.7. So far, it looks pretty good. So my opposites over adjacents are matching, which is nice. Next, we're going to do KQ over JQ and then LP over JP. So we're going to have to figure out which ratio this one is. So KQ, again, is this side, which is the opposite side from angle J. So that's 2.2. And then I want to look at JQ, which is this side right here. This is the hypotenuse. So that's 3.7. So it looks like this ratio is opposite over hypotenuse. So let me divide this. 0.6 once you round it. Okay, so I did the opposite over the hypotenuse of the small triangle. Now I'm going to do the same thing for the bigger triangle. So I want the opposite, which is LP. So this side here is the opposite side. That's 3.8. Divided by, I want the hypotenuse of the big triangle, which is this one here. And that's JP, which is 6.5. And let's divide that. That one also equals 0.6. 0.6. So our opposites over adjacents match. Our opposite over hypotenuses, I don't think hypotenuses is right. I'm not sure. Are matching. So now we only have one ratio left. That has to be the adjacent over hypotenuse. And we have to see if those match. So let's go ahead and do that. All right, so JK is this side here, and that is the number 3, divided by JQ, which is the hypotenuse. So that's 3.7. 3 divided by 3.7 is 0.8. So that was adjacent over hypotenuse for the small triangle. Now I'm going to do it for the big one. So JL is this side here. That's the adjacent side. That's 5.3. Divided by the hypotenuse, which is this side here. JP, which is 6.5. And they should match. Let's see, divided by 6.5. That one also is 0.8. All right, so we just proved that these two triangles are not congruent, are similar because of the ratios. No, it's not really necessary, Eric, if you can't fit it. I always just do it so people clearly see that there's like that point in front there, but you don't have to write it. I think when I was in school, I never wrote the 0. All right, so underneath these, I want you to write this down. So for the first one, we did opposite over adjacent. Adjacent. That was the first one that we did. The second one was opposite over hypotenuse. And this last one was opposite over, no, it wasn't. It was adjacent over hypotenuse. Adjacent over hypotenuse. You scroll up just a little bit there. There we go. So I'm going to give you a minute to finish writing this up before we move on. We're going to do the same exact thing on a new triangle. Okay, I'm going to leave the calculations up just in case you're finishing those. And then I'm going to start drawing the new triangles. So this time we're given a 45, 45, 90 triangle. Doesn't change anything we're going to do. It's just we know that that's a special right triangle. So I'm going to create a small triangle inside of this big triangle. Okay, so on the hypotenuse, you're going to pick any point you want on there and just put it there. And you're going to bring a line down, make it perpendicular to create that 90-degree angle there. And then we have two triangles. So I'm going to make mine bolder so you can see them a little bit better. You don't have to. Oh, and we're going to label this as DE. So let me make mine bolder. I always do the right side wrong. Okay, it's going to have to be squiggly. Okay. DE, so is it would be, Jonathan, yes. They don't ask you for that this time, but it would be. You could prove without any numbers, you could prove that these are similar by angle because they share that 45-degree angle and then they both have 90 degrees. So have this drawn. Make my E a little bit better on the bottom there. Okay, I'm going to scroll down. Hope we're okay. Let me know if you're not. Okay. So we did number 1 already. We drew in our triangles. Again, they don't ask you this time to use angle because it would be the same answer. So, but I'm gonna give you the measurements again, and we're gonna do the same ratios and see if these two triangles are similar. Okay. So make sure you draw this on number 2. These are the ratios we will be taking. Let me fix that D. That D doesn't look very good. I feel like that one doesn't look any better. There you go. Okay. All right, so I'm going to start giving you the measurements. So write these down. Put a page in my notes. Okay. So the hypotenuse on the bigger triangle, AB, that is 6.8. The right side on the big triangle is 4.8. And then the bottom, remember this is a 45, 45, 90. So that means that the two legs are the same length. So the bottom is also 4.8. The hypotenuse on the small one, coincidentally, ends up being 4.8 as well. Not related to the other two 4.8. It's just when you measure it, that's what you get. So hold on, 4.8 on the hypotenuse there. On the right side of the small triangle, it's a 3.2, which means that the bottom also has to be 3.2. 3.2. And we're going to do the same thing. So we're going to start dividing these and seeing if they're similar. So ED is this side right here. Oh, and by the way, angle 45 degrees, that's our reference angle right there. So D or ED, that's your opposite side. That length is 3.2. divided by, I want AE, which is this side here, that's your adjacent side, which is also 3.2. That's easy, that equals 1. So I did opposite over adjacent. Okay, now I'm going to do the same too on the other triangle. So I need side CB, which is the opposite side, this side here. That's 4.8. Divided by the adjacent side, which is the bottom. That's also 4.8, and that equals 1. So these two ratios match. Looks pretty good so far. On the next one, ED, so ED is this one here. That's the opposite side, that's 3.2. Divided by AD, which is the hypotenuse here, that's 4.8. And if you plug that into your calculator and round it, you get 0.7. So now I have to do the opposite and hypotenuse on the bigger triangle. So here's the opposite side, CB, 4.8, divided by AB, which is the ooh, no. Hold on. Undo. There you go. Which is this one right here. That's 6.8. So 4.8 divided by 6.8, that ends up also being 0.7. So we've done opposite over adjacent, opposite over hypotenuse. So all that's left is adjacent over hypotenuse. So AE is this side here. That's 3.2. Divided by AD, which is the hypotenuse, 4.8. And that equals 0.7. Okay, I have to do adjacent and hypotenuse on the big triangle now too. So triangle, or the side AC, which is this side here, that's 4.8 divided by the hypotenuse of the big triangle, AB, which is 6.8. And that also equals 0.7. So again, we proved that these two triangles are similar using the ratios for trig that we're going to be using. So underneath these, again, write opposite over adjacent. This one was opposite over hypotenuse. And this one was adjacent over hypotenuse. And I'm going to give you guys a minute to write this down. Okay, I'm going to scroll down a little bit and we're going to highlight something. So Jonathan, your participation is being based on answering in the chat today. So if somebody didn't answer in the chat, I'll leave them a message on Google Classroom saying you need to upload your pics because you weren't participating in class, okay? All right, so I'm gonna leave the calculations up, but I'm gonna scroll down. So if you have a highlighter, this will be where you wanna highlight, or I guess you could underline or circle if you want. This will be where we finish up today. So it says here, you know that the hypotenuse of a right triangle is the side that is opposite the right angle. In trigonometry, the legs of a right triangle are often referred to as the opposite side and the adjacent side. So we're not doing small, medium, and large anymore. These references are based on the angle of the triangle that you are considering, which is called the reference angle. So we want to highlight that. These references are based on the angle of the triangle that you are considering, which is called the reference angle. So of course, we know we have to bold our reference angle because that will determine our opposite and adjacent side. It says here the opposite side is the side opposite the reference angle. And then the adjacent side is the side adjacent to the reference angle that is not the hypotenuse, right? So there's two sides next to the reference angle. The one that's not the hypotenuse is the adjacent side. And then it gives you this little picture here, which we actually did one yesterday, right? You guys have your little cutout, or if you didn't cut it out, you got it written down somewhere, okay? So that's it. So that's what we're doing today. So we proved triangles were similar using the ratios that we're going to be using in trig. I don't think I was supposed to do this with you guys in like for your notes tomorrow. However, I think I might make it group work because it's really easy and it would just give you some practice identifying. So I might upload a group work activity for tomorrow. Do you guys have any questions? The timer's going to go off like any minute now. No? All right. Well, if you're done writing your notes down, my alarm's going off anyways. So I'll see you guys tomorrow. Bye.
Steven?
Yes.
Question. So I'm at my dad's right now, and I forgot to bring my